So my name is Derek Weitzel, and I'm going to be talking about data. And so if you've attended the other public lectures this week, you've already discussed how to identify an HTC job, how to submit using HTCondor, how to submit on the OSG, and how to kind of bottle up your software dependencies, and how to consider how do you bring software along, or what do you need to bring along with your job. And today we're going to talk about data on the OSG, input data, output data, how do you handle data dependencies in your job? How do you transfer these dependencies to the execute node? So I always like to think of the OSG as more of a spectrum, from your laptop to a cluster to the OSG. Every step along that way, you get more resources, but each one requires more planning. So you can't control, for example, you can't control a cluster like your laptop. You can't install your software anywhere you want and place files anywhere you want. But on your laptop, of course you can. You can rearrange software or files on your laptop to your heart's content. In the OSG, OSG is borrowed resources, so it's even more restrictive, including the network and the disk, along with the computational power. You're not able to on the fly troubleshoot things. And so you're not able to install software or have files already sitting there on the OSG. You have to bring them in with your job. But there are benefits to this. On a cluster or OSG, you get access to 1,000 or more cores. You can automate job tasks with HTCondor. And of course, you don't burn up your laptop when you're running your own processing. So I'm going to be talking about some of the different file transfer mechanisms. But I want to start out with what is big data? And of course, big data is relative. What's big data for me is not necessarily going to be what's big data for you. And I like to categorize things in volume, velocity, and variety. And that's what makes data difficult to deal with. Whether it's 1,000,000 1 kilobyte files or one large 1 terabyte file, both these could be considered big data just because it's difficult to work with these two ends of the spectrum. And when I talk about data and input and output, I'm mostly talking about any files that are needed to run a job, whether that's the executable, anything you may have put in like transfer input files on your Condor submit file, or any data and software you need to bring along with your job in order for it to execute correctly. And the output is any files you need to bring back. Most of the time, you'll always want to bring back the standard out and the standard error for your job, just for debugging and to see the progress of the job. But there's other things you may want to bring back as well. You want to bring back the results in BLAST. You want to bring back like the resulting text file. So just to go over some data management tips with you. You really want to determine your per job data needs, and you want to minimize your per job data needs. Determine what the smallest amount of work you need. What's the smallest amount of data you need for that work to succeed? And then use HTCondor and OSG data handling features in order to manage that data with your jobs. So first, to try to minimize your data, you can split large input for better throughput. Now, this is dependent on the application. Some applications you're able to split the input. Some applications require reading the entire input data set all the way through. But a lot of applications, you don't need to do that. You want to eliminate any unnecessary data. For example, if you're running I'm going to keep on using BLAST as an example. If you're running BLAST and you download all of BLAST from NCBI, it comes with a lot of different executables. You may not end up using any of the other ones. Maybe you only need to use BLASTX. So only copy that BLASTX out of the executable. You'll save hundreds of megabytes of data transfers for each job if you only take the executable that you need out. And then file compression and consolidation. For input, you can compress your files prior to submission. For output, while your job is running, you can compress it at the end of the job before it's transferred back to the submit node. And then it's useful to compress it when you're moving data between your laptop and the submit server, so you're not moving as much data across the network. And so it's faster in that way. So I like to put an analogy of data. We have different data mechanisms for different levels of data. The same way that you have different data transfer mechanisms just in the real world. For example, if you were going to send data to your collaborator, how would you do it? If it was a small amount, if it was just like a couple of words or a couple of numbers, you probably just send it in an email body. If it was still pretty small to maybe 100 megabytes, you'd send it as an email attachment. If it's getting even bigger to 100 megabytes to a couple gigabytes, maybe you'd upload it to Google Drive or Dropbox or some other web accessible repository and send your collaborator a link. And finally, if it was in the terabytes, which certainly happens, you would probably ship an external hard drive. And we've seen that done frequently now. So never underestimate the bandwidth of a station wagon full of tapes, or in this case, hard drives, hurtling down the highway. This is a famous quote. And it is very true that many collaborations ship terabytes across the country, hard drives. And maybe they don't necessarily need to, maybe the environment requires them to do that, but that's just another method of delivery. So just like we had a spectrum with the laptop to the cluster to the OSG, we have the same spectrum with transfer mechanisms. On the left, we have HTCondor file transfer, which you've probably already used in the previous day's exercises. HTTP proxies and stash we'll talk about today. And then finally, local storage, which we'll just touch on today. So as you go further to the right, you're able to handle more data, but at the same time, it's a little bit more planning at each step. So the same way that we had that diagram or of that table of how to send data to your colleague, this is how to send data to an execute server. So if it's really small, like words, then just put it within the executable or in the arguments to the executable. If it's still pretty small, up to 100 megabytes per file, use HTCondor file transfer. It's built into Condor. It'll work at every site. Now, if it's 100 megabytes to a gigabyte as shared data, in other words, it's shared between many jobs, so there's some data reuse there, you can use a web server with local caching, and we'll explicitly talk about how that works here in a minute. If it's a gigabyte to 10 gigabytes, whether it's unique or shared data, you can use stash, which instead of using local caching, it uses regional caching or regional replication. And then finally, once you get a little bit larger, then you are getting into the realm of shared file systems. And sometimes these type of jobs that are getting quite a bit larger than 10 gigabytes, you're quickly becoming not an ideal candidate for the Open Science Grid. So moving on to talk about HTCondor file transfer. So if you've followed along with the exercises, you've probably already seen the transfer input file. So what it does is on the submit server, when the job is submitted to the execute server, it also brings along all these data input files. And then it on output, it brings all the output back. And this is just using HTCondor file transfer between the submit server and the execute server. Of course, the problem is that many jobs can start up at the same time, and they all need that input data. And so the submit server is overwhelmed with transferring all this input data to the execute server. So they may coincide, the input file transfers may coincide. Now, most of the time you're lucky that the output transfers, the jobs may not finish at exactly the same time, and therefore those are staggered, but likely the input transfers may happen all at the same time. And so we have some limits, some guidance. If it's less than 100 megabytes a file or 1 gigabyte total for the entire job, it's okay to use HTCondor file transfer. And then if it's less than a gigabyte per file and total for the output. So I'll talk about Web Proxy and how to use that. Remember, this is in the 100 megabytes to 1 gigabyte, downloading it from a web proxy. So just a little bit bigger than you would use for the HTCondor file transfer. So what you do is you place a file on a local web server, and you have HTCondor download it via the HTTP address. So what happens is you have a file, and it's attached or installed on this proxy web server. And every site, most sites, I'm sorry, have this web cache. And so when your job starts on the execute server, it will ask the cache for this file, and the cache will then download it from this web server, store it temporarily in the cache, and then transfer it to the execute server. Now, what's great about that is then each subsequent request for that exact same file will not go back to the proxy web server. Instead, it will hit the local cache and only the local cache. And this is how it looks when you do it in the submit file. You do transfer input files and then the web address. Now you can use almost any web server, but you don't want to overwhelm maybe non-friendly web servers. This is very easy to get blocked if you're downloading too much from a website that you don't control. And there are some considerations when using this web proxy. Your max file size is 1 gigabyte when you're doing this. Local caching at the OSG sites, it's great for shared input files, perfect for things like software, which you're going to use the same software for lots of jobs, and common input. But you want to be sure to rename the files every time you change it, every time you update the file. That way you always know you're downloading the newest and greatest version of that file, and you're not getting some old copy that happened to be on the cache. And files can be downloaded by anyone who has the HTTP address. So you want to make sure that these are public files. But this will work on about 100% of the OSG sites, though not all sites will have a local cache, but the vast majority of them do. So again, how do you do this on OSG Connect? And this is in exercise 2.1. You put the files into this special directory in public username, and then the address will be translated into this HTTP address. The file will be available under public, your username, and then the name of the file. All right, let's talk a little briefly about Stash. And again, this is where we're at. This is the 1 gigabyte to 20 gigabyte unique or shared. So Stash is a regionally cached repository managed by OSG. So you'll see on the left in the United States, all these dots are the locations of the different caches. You'll see a lot of dots that are along these are network backbone lines. We have a lot of caches that are on the network backbone, thanks to Internet 2. And then we also have a few international caches as well that are used by different experiments. And I wanted to show you, this is a graph of the usage of Stash over the last, I think, 2 weeks. Now, a lot of the green bar is the Minerva experiment out of Fermilab, which is a neutrino experiment. They've been using it a lot lately, but so has OSG Connect users. There's several OSG Connect users, I pointed to 2 of them there, that are using Stash Cache for their experiments. So for the considerations for Stash, it's available at about 90% of OSG sites. Regional caches are on very fast networks. The recommended max file size is 20 gigabytes, whether it's shared or unique data. And what I mean by shared is it's shared between multiple jobs, or unique means only one job will need this data. Both can be used on this, and the exercises have examples of both shared and unique. You can copy multiple files totaling greater than 10 gigabytes, but we do like to keep the max file size down. And just like HTTP that I mentioned before, please change the name when you update files. It doesn't have the users are not able to control when the file will be deleted from the cache. And so you don't know if you're going to pull down the new file or an old version of the file. unless you update the name of the file. So the way that this works on OSG Connect is users will put files in their public and then their username on OSG Connect on the login servers. And you'll see that I've already put it on the stash origin, the files there. And then from any submit node, I submit the job. And when the job runs on the execute server, it will use this special command -cp, which will contact a regional cache and ask it to download the file from the origin. So the file will go to the cache and then finally to the execute server. And then subsequent requests of that same file will only reach the cache. It will not go back to the origin. And these caches are very high performance on very fast networks with very fast disks. And so these are optimized to be fast caches. And in the submit file, you need to add a few things. You have to do require wants stash cache equals true. And then also in your requirements, you need modules in order for the stash CP tool to work. And so you just have to add this one statement at the end. And again, the exercises will explicitly list these. So the job executable, this is just an example wrapper script. It would look like this. You would load the stash cache module, and then you would do the stash cp command to actually download the file. You would untar it. I download a tar file, do whatever job commands you normally do, and then be sure to remove all the files. Because you're downloading these files outside of HTCondor, it doesn't know if these files were created by the job. So it's important to remove all the files you downloaded through stash cp before you end the job. So let's talk a little bit about output. So output is almost always unique, right? So caching won't help with output files. And files, you need to have them associated with your local username. There's a lot of security barriers. For example, if you submitted your job at OSG Connect and you ran at Nebraska, how is Nebraska supposed to know that you are, I'm just gonna use my name. How is Nebraska supposed to know that it's Derek Weitzel's job and I can assure you that Derek Weitzel should be able to write back. And so there's a lot of security issues. And if you want to make it world writable, okay, that's a large security issue with a world writable. So we have done some work, and I'm going to talk about the different transfer methods. So if it's a small amount of output data to tiny to 1 GB, you can go ahead and use the HTCondor file transfer. If it's larger, 1 GB to 20 GB, you can use stash as a write, as an output. And then if you're getting larger than that, then you have to talk about shared file systems. I'm going to talk quickly about stash, how that works. So in the submit file, again, you want to have that wants stash cache and the same requirements as before. But in the job, instead of stash CP has very similar format as CP, for example. So in stash CP, you copy it where you say, where do you want to send the data? And in this case, my data is output.dat. And then I tell it to contact stash and save it into my stash username. And we handle all the security in the behind the scenes in order to make that work and secure. So going back to input files, each one of these inputs, transfer methods, have different options, come with limitations on site accessibility. Not all sites are going to support stash. Not all sites are going to have a web server. The vast majority of them will. But if you HTCondor file transfer will support every site, but it won't scale as high. So it's a trade-off. And I want to make sure, I think I've already mentioned this before, but for stash and web proxies, be sure to delete the data when you no longer need it. These servers are not unlimited space. And if you get too large and too old of files, we will hunt you down and contact you. We've done it before. But so please be sure to delete any data when you're done with it, when you're done with your workflows, when you're done with your process. I want to briefly touch on shared file systems. So data stored on shared file systems are data stored on file servers, network mounted to both the submit and the execute nodes. Now this is available at the CHTC, but it's not available at OSG Connect. And there's more details if you want to download this presentation at the end. We have file system quotas, both at CHTC and OSG Connect, and I list them here. For OSG Connect, they're 50 gigabytes for the home, and then for the public, it's 500 gigabytes. You can access data in the public through Web Proxy or /CP, but the home directory is only available through HTCondor file transfer. Then I'm going to end here, and this is the quick reference where it shows all the different transfer methods, whether it can be used for input or output, the file size limits, how to get the files into those locations in order to use them, how do you download the files, and then whether it's the accessibility, whether it's can run anywhere or whether it's only on OSG most sites or only at a local cluster. And then I just talk over the exercises. Are there any questions at this time?